Right before I came up here, the person sitting next to me said, "Wow, that was a really inspirational talk, and you have to follow it." So bear with me. I'm going to be very... I won't name him, but I will be technical about some of the issues that we deal with. So this past year has been interesting. There's been a lot of change, a few bouts of uncertainty, but the big thing for me is the product, MySQL, is a lot better this year than it was last year. And it looks like we're going to see more of that continuous improvement over the next few years. So as a customer, that makes me very happy. At Facebook, I'm a software developer who does some operations work, but I get to cherry pick the work I do in operations, so that's a bit easier for me. I would urge all database developers to spend time fixing things in production so that you realize what features your products need. So I'll give an overview. And actually, it would be nice if I could announce an internship project, but to do database production internships. For now, just read the blogs from people who are solving these problems. I'll give a quick overview. I have about 18 minutes left. Fortunately, there's 3 other talks from my peers at Facebook at the conference, and they will go into much more detail. The slides that I borrowed from them for this talk will be explained completely in their talks. I'll cover how we use MySQL, how we keep it happy, and the challenges that we face over the next 12 months. So what is MySQL at Facebook? And I promised details in this talk. The first one is X thousand servers. It's not a typo, but that's the only number that's not fully specified in this presentation. So more numbers will follow. X is probably larger than we want it to be. We'd like to save power. We think we can maybe not shrink X, but be more careful about letting it increase over time. And with the new 5.5, I think will help a lot in that regard. It's sharded MySQL with several shards per server. We use master-slave replication. I joined in June of last year, and we were using 5.0.44 at the time. In the past few months, we've done 2 upgrades, and it's remarkable that at least the last upgrade went extremely fast. It's nice to see because we have a lot more features we want to push into RPMs and get them deployed. The first upgrade was to 5.0.84 with a few patches, including the big one was the patch to protect the LRU for InnoDB that InnoDB and MySQL support provided to us. And then the second release of 5.0.84 had a much larger patch set. We use InnoDB. I am the biggest InnoDB fan, I think. Heikki did amazing work. Ken Jacobs added to that tradition. He also made InnoDB better. I think he had a big part in the documentation that InnoDB has. And now the InnoDB team continues that, so I look forward to that. And we run memcached in front of MySQL. The workload is traditional transaction processing. We have lots of fast, or usually fast queries, and some of them have simple joins. Some of the stories I read about sharded MySQL state that you don't do joins when you have sharded MySQL, and that has never been the case for the workloads that I watch. You're always doing some complex query processing within a shard. We have lots of fast transactions, and fast is, I would say, 100 milliseconds, where the typical transaction size has 4 or 5 statements. Secondary indexes are critical for performance. I have a couple of times I will mention that index-only queries are the key to good response time when you care about response time on top of MySQL. And we have some rows in the database that are very frequently updated. So here are the numbers. Query response time is measured from the client, the application perspective. 7 milliseconds per write and 20 milliseconds per read. Other way around. 7 milliseconds per read, select statement, and 20 milliseconds per write, which would be an insert, update, or delete. Network traffic per second, more than 20 gigabytes. Queries per second over all of this. These are numbers over all shards. Queries per second is 10 million or more. Rows read per second, we peak at about 370 million. While it maybe other people would not be happy, I think we can get up to 1 billion per second easily, and that would be a nice round number to reach. Rows changed per second is much smaller. At peak, it's about 3.5 million. This is the type of workload I like to see. We're reading data much more than writing it. If you're only writing the rows and never reading them, then I wonder about the value of that data, because you're spending a lot of money on disk I/O to update it. About 4 million disk operations per second. And here, by disk operations, I measured this from the 16 kilobyte page reads and writes done by InnoDB. This is not coming from IOstat. The team. So when I arrived, the team had 3 people in operations and 1 person doing performance, and I'm not sure if anyone slept. They spent a lot of time fighting fires. Now we have 8 people in operations. They have time, some time to do strategic projects, and we have 4 people hacking on MySQL and working on performance. We have a few impossible goals. We never want to reject a connection attempt to the database, and we always want to finish queries on time. We have a couple of classes of response time goals. Generally, it's intermittently impossible to meet these goals. We'll have a server that gets busy for some reason, and at that point, we need to shed load in priority order. We're slowly building tools to do that, and Domas, in his talk, after this talk, will describe some of that work. The other big thing for us is we need to get more QPS per database server. What we do, we make things better. We fix queries, we fix our schema, we fix our processes and best practices, and we fix our schema systems. When things break, we have to fix them. We can't wait for an application fix. That might take a few days. We can't wait for MySQL fix. It might take a while to push a new RPM. So we have to invent. We have to be clever about how we fix things. And the other thing is Facebook likes to talk about moving fast. On the infrastructure side, we don't move fast. We make it possible for the other people at work to move fast. Make MySQL better is one of the things I like to say we do. We need to improve performance, manageability, and availability. The big thing for performance is modern hardware. Many servers with many CPU cores and high I/O capacity are commodity today or tomorrow, and we need to get MySQL to use that capacity efficiently. The other thing is we have highly concurrent workloads. We have periods in which there's several hundred queries running concurrently on a database server, and we need to make sure that the throughput on that database server does not degrade significantly. For availability, again, we want MySQL slaves to be crash-proof. A big thing for us is crash recovery and restart time. If you want to upgrade an RPM, you need to shut down the server. That takes about 15 minutes to do shutdown, restart, and then have the server be usable after restart. We think that with some software changes, we can get that down, at least for a planned restart, that we can get that down to much less than 30 seconds. maybe a minute. But it's an easy thing to fix. And InnoDB announced crash recovery will be faster. The big thing for us for manageability is just monitoring. We want to know where the load comes from on the database server. And it's usually our problem, not the problem of the applications creating the load. So we have to somehow solve this on the database side. A key point, definitely not the problem. I read a lot. From what I read in public and then what I experience at work, it gets blamed too often because there's lots of things that can make performance get bad. Part of the problem is that there's not enough monitoring in MySQL, so it makes it easier to blame MySQL. Another part of the problem is that performance debugging is hard. This is really something where you need to bring in experts to help you figure out what's going wrong. And I would just hand-wavy, I would say 1/3 of the problems we have are in MySQL and 2/3 are elsewhere. Some typical problems we have, I wrote a big blog post about paging via using a limit clause with an offset. So if you're running a query like for every page, and let's say that 100 rows are being fetched from the sequence of statements, then MySQL would process 10,000 rows. And if you do this pattern to fetch 1,000 rows, MySQL would process 1 million rows. This doesn't scale. Another problem is that you need to think about the common case when structuring transactions. We have a long tail of rows in the database that don't have much activity on them, and then we have a few that are very frequently updated. Our transactions need to be structured to run fast for the frequently updated rows. One of the things that is frequently done is locking is the code, the transaction assumes that the row doesn't exist, and it might do an insert on duplicate key update. So it's an insert, assuming the row doesn't exist, then if it does, the update path runs. This is doing much more work in the case when the row exists. We also have some transactions that just are too long. If you have a very popular row in a database, and the typical transaction locks that row for 5 milliseconds, then you get 200 updates per second on that row. And in some cases, we need a much higher rate for that data. Finally, the key is the MySQL allows you to put a comment in your query. The people who write the queries are usually not the ones who debug production. So they need to put the things in the query that we need to debug. If you're using memcached, put the key in the query comment. Put the ID or the IP address for the memcache server. Put the reason for doing the query after a memcache miss or a timeout or some other problem. And give a pointer to the code in the query comment so that we don't have to spend half an hour grepping our code base to figure out where the query comes from. Make our schema better. The big thing for us is index-only queries. We have a few popular queries still that are not index-only, and so they depend on the contents of the buffer cache. When the cache is cold, they do too many disk reads. It would be good to remove unused indexes, but you need a patch from Percona right now, or the Google patch, to figure out which indexes are not being used. And use the InnoDB bonus. Primary key scans are index-only. Primary key columns are in all secondary index entries. So you have a better chance of being index-only on the secondary index. And the insert buffer reduces the cost of secondary index maintenance. So having an extra index might not be as expensive as you think. We continually try to improve our processes and try to enforce best practices. Connection limits per database account are very critical for us. When you have connections, eventually your database server will have too many queries running concurrently. So we use the connection limits as a proxy for the per query limits. And then the only problem is it's a weak proxy because we'll allow many more connections than we would want queries. We're working on this. We will probably have a patch to enforce per account query limits, and then we hope that this gets into the official releases. There's a few problems that we frequently get from features that don't work well together. The one I'll state here is when you run flush tables with read lock on a busy master, that can create a pileup on the server because of the implementation. And we have a patch for this, and I think, I'm pretty sure MySQL needs it too, and I know they are working on it. I just have not heard the outcome of it. The other thing is we just frequently learn what we are not monitoring and figure out new things to monitor after the fact. Make our systems better. We've had a lot of obscure latency problems usually on write statements, insert, update, delete. Many of these turned out to be based on the file system issues. We switched from ext3 to XFS. That was a big change. Learning how to properly set up XFS on a server. Changed the I/O scheduler from CFQ to deadline. And all of these have had a significant impact on getting rid of the outliers from our performance. So how we do it, we get a lot of help from others. We read source code, documentation, search Google. There are a lot of answers out there, and sometimes these answers are correct. And then we hack and then automate. So we write a lot of ugly shell scripts to try to fix a problem, and then if they turn out to work, we will convert them to Python or Perl or PHP and run them from cron. And clever name. I like to name the tools. Domas and then the operations team will talk much more about that. Help from others. Who helps us? MySQL support. They know a lot. They also advocate for us. I don't know if Harrison is here, but Harrison gets the brunt of my unhappiness at times via support, and I'm a big fan of them. Facebook Operations gives us a lot of support to run a service at scale so that we don't have to constantly respond to interruptions. MySQL 5.1 has turned out to be a great release. So, surprise, 5.5, I think, will be better, and I really want to try the InnoDB features. I am just quickly going to say Percona teaches us a lot. I read their blog, and I borrow or copy a lot of the work that they do. And MatKit, there's several MatKit tools that we like. How do we fix MySQL? Frequently, we have to tune it. The key to tuning is you need to give us a way to tune the variables. If we have to restart the server, that's painful. The worst thing you can do is put compile time constants in your code based on assumptions from 1995. Domas will talk more about that. Performance debugging. I will give you the world's best performance debugger. It's called Poor Man's Profiler. This is another Domas project. It finds a lot of bugs. It tells you where things are waiting, which is what you want to know for a database. Frequent queries. What do? We use TCP dump. Eventually, we will use the slow query log and MK query digest, and it sounds like the query analyzer is going to support for a lot of customers the similar type of analysis we need to do. This is what I frequently use today to figure out what are the top 5 queries on my database server. Challenges, multi-master replication with conflict resolution we need. Modern hardware, people are selling devices that can do 100,000 IOPS per second. We need MySQL and InnoDB to efficiently use that. We need online operations, resharding, and splitting a database, resharding. Long-running schema changes. We need throughput to remain constant under load. I'll show you a graph. I am not a booster of my ISAM, but it does much better for maximum I/O than InnoDB. And I'm running out of time. So constant throughput under load, the graph used to be the gray line on the bottom. That was MySQL 5.0. This is a bogus graph anyway. Present is pretty much the purple line, and we are targeting the yellow line. MySQL 5.5 looks like it's a lot closer. The future, this is it for me. MySQL must share the database, or the data center, and the data with new servers, HBase, Cassandra, Hive. These are not going away. We need to learn how to work with them. Action items, there are 3 talks from Facebook. Domas has one right now after here. There's one on Wednesday and one on Thursday. Thank you.